Welcome to the fifth and final part of the mini oil can series. By the end of this video, the oil can will be complete. Hello and welcome to another video by Best Lathe Plans. In the last video you saw me make the pump inlet mechanism, which you can see in all of its glory on the screen now. And today we will be finishing that part of the build, so let's have a look and see what we will be making today. As you can see here, the drawings for the pump outlet body are here, and you can see there's a few different operations that are needed to be performed. There is a blind hole from the top which is at 3 different diameters. There's a tapping diameter 3BA at the top, which is for the gland nut. There's an internal volume which has clearance for the ball bearing. And at the bottom there is the ball bearing valve seat, so this has to be a narrower diameter than the ball bearing. And if it's not obvious, the fluid will be pumped in this direction. The outlet housing will be connected to the inlet housing using a short length of pipe, which will be connected here. Lastly, the other components required to finish the build are the gland nut to screw into the top of the outlet body and the outlet pipe. So let's head over to the lathe and get straight into it. Here we're using the same material as for the pump inlet body. It's 12mm brass round bar. This length obviously is shorter because I've already cut the pump inlet body using the same length. Step 1, let's reduce the diameter down to the correct size. The plans say that this diameter is 5mm, so that is what we're aiming for. I've obviously shortened this process here, but as you can see I was getting a horrible finish, so I changed the tool to a diamond tipped cutter, which seems to give me far better results if I am very slow on the feed rate. So now we're down to size. Let's get started on the internals of the pump outlet housing. The first thing I'm doing is drilling the middle sized hole. This is going to be to a depth of 20mm and a diameter of 3mm. Next up is the valve seat recess. This is the smallest hole at the bottom, and this is at a diameter of 1.5mm and an extended depth of 3mm, making a total depth of 23mm. And lastly, it's time to drill for tapping size 3BA, and that is 3.45mm to a depth of 6mm. Hopefully it won't be too short like I did for the inlet and then have to re-tap it. So the last operation is to just put a quick screw thread in the top. That's 3BA, and this has gone quite smoothly, thankfully. So now we're just going to part it off. The last thing this part needs is to be cross drilled through the bottom to meet with the smallest 1.5mm hole. We will do that separately once we've finished all the circular turning on the lathe. Once I'd measured the length, I parted it off, flipped it round and cleaned up the other end. Once that was neat, that's the finished outlet housing, and it's beautiful. So next up is the gland nut. This is identical to the one for the pump inlet housing, and this will be using some 6mm brass hex bar. This has 3 operations on it. First, we'll spot and center drill and then do the through hole. Second, we'll turn it down to threading diameter of 4.2mm. That's threading diameter for 3BA. Then we will thread it 3BA. Then we'll neaten up any sharp corners and then we'll part it off. So yeah, that's 5 operations, not 3, but pretty close. Luckily, my machining is better than my counting. Okay, so step 1, drilling, that's pretty easy. Step 2, we will now turn to threading diameter, which is 4.2mm. Again, fairly straightforward and non-eventful. Now to thread 3BA. This is easy too. Okay. Apparently my machining isn't as good as my counting. Maybe I'll thread it before drilling this time. So, take 2. Okay, first we're going to reduce the diameter, then we'll thread it. Now we'll drill it. And now we'll part it off after cleaning up the sharp edges with a file. There's a small pip from the parting off which I will remove with a file and sandpaper, but otherwise this part is complete. So now we need to set up the vertical milling attachment on the lathe to drill the cross hole. We'll do this in the same way that we did for the pump inlet housing, and it went surprisingly well. It did take ages to get set up and set the vise up and the vertical slide and everything. However, once it was done, it was pretty easy. And back to the plans, and as you can see, we've now almost all the bits that we need. Now just need to make the pipe to connect the pump inlet and outlet housings. I'm using a very short length of very small diameter copper pipe. I think it's about 2.3 millimeters in diameter. For people who aren't familiar working with copper, it bends a lot easier if you anneal it. That is, basically heat it up till it's glowing red and then let it cool down. So I annealed it and bent it first, then cut it to length. It's easier to get a nice bend when you're using a longer piece of bar, and you can cut off the two straight bits at the end. So once I made this, it was test fitted with all the parts in place, and now it's time to secure it to the pump inlet and outlet. I tried this first with Loctite 270, but for some reason this isn't holding very strong, probably because the mating surface area isn't that big. So it's back to the old reliable silver soldering. So I did this with all the parts balanced in place on a gas burner for my steam boiler. This reduced any blowing or wind effect which I get from using the flame on the blowtorch. You need a steady hand to apply the silver solder here, because if you hit the pipe it will fall over, which obviously is not good, but if you're careful it can be done quite easily. Unfortunately, because I'm using the gas burner, the flame from the burner actually melts the wire pretty quick, so unless you are quick yourself, then you risk doing what I've just done, which is melting a big lump of silver solder onto your part. Luckily it's only 0.5 millimeters, so this will come off quite easily with a file, but it is a bit of a waste of silver solder. For people curious, I'm using a 0.5 millimeter silver solder wire and easy flow flux. So now the parts are joined together, we'll put them in the acid bath to clean up and wait, I guess. I know I said we were going to follow the drawings, but I've decided to put a nice brass tip on the end of the outlet pipe. So here you can see me just sketching out a rough design before heading over to the lathe to machine it. And we'll do this whilst waiting for the pump mechanism to clean in the pickle bath. The plans don't actually show any tip on the pipe, but I think this will polish up to look really quite nice. I'm not really doing any measurements here, I'm just going by eye. It's basically a short tapered piece of brass with a double diameter hole drilled through it. The larger diameter is so that the pipe can slide inside of it, and then the tiny diameter is for the fluid to squirt out. I made another silly mistake here where I did the taper the wrong direction the first time round, and that's because I need to do the larger hole on the left of the screen. Obviously I can't drill a small hole leading into a bigger hole. I have to do a big hole leading into a small hole. So now you can see me just correcting that and cutting the taper back and then tapering the other direction. I used the normal chuck to drill the larger hole, and I used a small pin chuck to drill the tiny 0.4 millimeter hole the rest of the way through the part. And I know you maybe can't see that well here, but this part is actually tiny. Once it was parted off, I then mounted it to a straight length of copper pipe, and then mounted the pipe in the chuck to use as a mandrel to clean up the other end. And that's turned out really quite nice. I'm quite pleased with that. So now we have all the parts, let's get this assembled. The audio for this part seems to have disappeared as well, so unfortunately you just have my voice for this bit. And we have a small problem. Because the pump inlet and the pump outlet are mounted through the top at an angle, it was actually quite awkward to put them into place now that there was a length of copper pipe between the two of them. I'd also machined them quite a tight fit in the lid, so to give me a small bit of extra play I actually used an ice bath, which just made the process slightly easier. And now they're in place, it's time for problem 2. This is basically where I didn't use a short enough length of pipe and it's hitting the side of the oil can body. so it actually doesn't fit inside the oil can. But we will just head over to the vise and tighten it up in there, and hopefully that will bend it enough to get it to fit into place. It's then just a case of inserting the ball bearings, tightening up the 2 gland nuts, and we're finished. And that is the oil can in all of its fluid pumping glory. And that's the oil can finished, and it looks great if I say so myself. We'll do a quick test fill with some water to make sure the pump works, and that's it done. And that's the end of the oil can series. I hope you enjoyed it, and if you're considering making one yourself, make sure you get the plans downloaded. If you have any ideas for future videos, please leave them in the comments. And lastly, if you enjoyed the video series, please do consider subscribing to Best Lathe Plans. As always, stay safe, and I'll catch you in one of my other videos.